Hey there, Mr. Myestis here, and today in this video I'm going to go over arithmetic sequences and series. So this is kind of a pre-calculus. This is going to be a quick video, just kind of overviewing what arithmetic sequences and series are, and maybe giving you one example, kind of like get through what all this stuff is, and then I'll see if I can get a couple examples here for you, practice problems for you to do. All right, but I want you to at least be able to just understand what an arithmetic sequence is and what the difference between a sequence and a series is. And we'll take a look at some examples. So over here I have just kind of what an arithmetic sequence is. Now, a sequence, if you don't remember, a sequence is just a sequence of numbers in a row. And an arithmetic one is one that's put together by just adding a single number each time. Same number. That's called the common difference. So right here you see my D it's called the common difference. It just means that if I have a sequence, it's going to add that same number, D. I'm going to add that each time to the next number to get the next number in my series. So in my sequence, I'm sorry. And this is the formula that we use to find the nth term of an arithmetic sequence. This right here, a sub 1 is my first term. D is my common difference, and n is the term number that I want, and a sub n is the nth term. So let's take a look at an arithmetic sequence. 2, 4, 6, 8. Who do we appreciate? Mr. Maxis. So this is an arithmetic sequence, and it's arithmetic because to get to the next number, all we're doing is adding 2 each time. Right? We have here, we're going to add 2, add 2, add 2. So every time, since we're adding 2, that's an arithmetic sequence because we're adding the same number over and over again. And since we're adding 2 and adding 2 and adding 2, this 2 is our common difference. Okay? So that's what we're going to use as D. D is 2. So let's say we're looking for the fifth, let's do some of these. I already got 4 terms. Let's do something a little more difficult than that. Let's say we're looking for the 20th term. Okay, so let's say we're looking for a sub 20, right? The 20th term in the sequence. Well, we're going to use our formula for arithmetic sequences, which we have up here. So our a sub 1, our first term, is 2. Our D is 2, because that's what we just figured it was. And n minus 1, n is going to be which term that we want. So n is the 20th term, so we're going to plug 20 in there, minus 1. And we're just going to compute that out. So we're going to get 2 plus 2 times 19, which is 2 plus 38, and we're going to get 40. So 40 is our 20th term in our arithmetic sequence. Now, a couple things to remember when you have this. There's some other things you can do with it. We can come up with the formula for the nth term by just plugging in what we know and just keeping n by itself. So if we wanted to do that, and let's say these are all the even numbers. So if we wanted to come up with a formula for the even numbers, we would say a sub n is equal to 2 plus d is 2 times n minus 1, we get 2 plus 2n minus 2, and so a sub n is just, these 2's go away, just 2n. Okay, so this would be our formula. Notice here, this is linear, right? It's for any one that we want, we just have 2 times n, and this is a linear equation. So it turns out that arithmetic sequences, all arithmetic sequences, have a linear formula to it. All right, and you can actually graph arithmetic sequences in a graphing calculator. It's kind of cool. So let's take a look at what a series is. Now, a series is just a sequence added together. That's it. So if we took this 2, 4, 6, 8, who do we appreciate, and we added it together, we'd have 2 plus 4 plus 6 plus 8, who do we additionally appreciate. And that becomes a series. So a series is a sum. So I've got this classic series up here. This is arithmetic. 1 plus 2 plus 3 plus 4 all the way up to 100. And let's say we wanted to add the numbers from 1 to 100. And someday I'd say, hey, you you're acting pretty naughty. Why don't you sit there and add the numbers from 1 to 100 without a calculator? Do it now. Well, that's kind of an old story, math story that goes, a famous mathematician, his name was Gauss, they say, was acting bad in class, and he was given this assignment to add these, and he comes up like a couple seconds later and says, yeah, I got the answer. It's 5,050. They're like, what? How'd you do that so fast? He's like kindergarten, like second grade. It's crazy math. You know, really super genius math, okay? And he goes, yeah, well, he's probably littler than that. He has a little, 7th grade slur in there. But he says, I see that 1 plus 100 is, if I add those two up, do it this way here, if I add those two up, I get 101. And if I add 99 and 2, that's also 101. And if I add 3 and 98, you know what? That's also 101. In fact, I can add each of those end pairs, and they're all going to be 101, and I've got 50 of them, because I can keep going, 49 and 40. And I'm going to get to 50. I got 50 of them. So if I just take 101 and multiply by 50, I got my answer. Turns out to be 5,050. Yeah, this guy's super genius. What that ends up doing is it gives us our formula for the sum of an arithmetic series. So the sum of in terms of arithmetic series, we're going to take, what did he do? He took the first term and the last term and added them together. So the first term is a sub 1 and the last term is a sub n. So you take first term, last term, add them together. And then what did he do? He took the total number of terms, in this case there's 100 of them, and he divided that by 2. Because that would be how many pairs he had. So he's taking the total number of terms, which in this case is n, right? N is 100 terms. And he divided that by 2, and he came up with this nifty formula for the sum of arithmetic series. So if we wanted to find the sum of an arithmetic series, we wanted to find the sum of n terms of this one, we would just use this formula. All right? So that's it. That's all there is to it, guys. You put together these two things and you have arithmetic sequences and series. Now there are a lot of different types of problems you can get with these, but really it comes down to, can you remember this formula and utilize all the parts, okay? And can you remember this formula and the idea that you're taking the ends, a sub 1 and the last one, adding them together and divide and multiplying by the number of terms, divide half of the number of terms. If you could do that, it's really a matter of manipulating these two equations depending on what the problem is asking you to do. Really, all I could think of is, off the top of my head, real quick, they can ask you to find the sum. They can ask you to find the formula for a sub n. And they can ask you to find the nth term. They can ask you to find something called arithmetic means, which would mean that they would give you the first one and the last one, and then ask you to find all the ones in the middle. But you can do that because you got the formula. All right, you find the nth term. Okay, got a couple a couple things to do with that, but you use the formula, you get the answers. Okay, so there are other things that they can ask you, but as long as you can utilize these two formulas, you're good. All right. Any questions? Let me know in comments. Talk to you later. Bye.